Okay, so 3/6 is the quadratic formula and the discriminant. Whenever we can, we're going to try to do things without our calculator, but we are going to work with some larger numbers today. So for those cases, we are going to use our calculator. So if you want to have that out for the bigger numbers, you may. And as soon as I said that, I feel like a lot of people in my other classes asked me, oh, then is our next quiz going to be calculator? So your next quiz, in case you're curious, is going to be part calculator, part no calculator, okay? So we are going to solve equations using the quadratic formula. This is the fourth way we are learning to solve quadratics. So whenever you have a quadratic equation in the form ax squared plus bx plus c, okay, if that's equal, ax squared plus bx plus c equal to 0, where a can't be 0, because if a was 0, then this term wouldn't exist. And if that term doesn't exist, what type of function would we have? What's this? What's that called? A linear equation. Yep. Okay, so far we've learned how to solve by graphing, we've learned how to solve using completing the square, by factoring, and then our next way is the quadratic formula. So to solve, you are still finding your x values. So x is the opposite of b plus or minus the square root of b squared minus 4 times a times c. And everything is divided by 2a. When you are writing out your solutions with your quadratic formula, all of your solutions have to be exact and simplified. Okay, they must be exact and simplified. So we've been talking about the simplified part a lot. That is where you have to make sure there are no perfect squares underneath the radical. And if you need to reduce any fractions, you're reducing them. Okay, the exact part means that you are not going to have any decimals. Okay, so no decimals. You're going to keep them as radicals. Okay, so exact means no decimals. Simplified means you need to reduce and look for perfect squares underneath the radical. I'm just going to do the square root of a perfect square. Okay, so you have to make sure that you look for those. Okay, so this is going to tell you to find the zeros of each by using the quadratic formula. So remember, there's lots of words that can be used in place of 0. That's the solutions, that's the x-intercepts, that's the roots. Okay, so you are going to find the solutions for each quadratic equation. Okay, so for part A, we have f of x is equal to 2x squared minus 16x plus 27. All right, so one thing I like to do is I like to write out what my A, B, and C value are, so I know what I'm plugging in. So the A value is always in front of x squared, the B value is in front of x, and then your C value is 27. Okay, and then we're going to plug this in. So this is the opposite of b, so we're going to have positive 16 plus or minus b squared is negative 16 squared minus 4 times a times c divided by 2a. Okay, so these are some bigger numbers underneath the radical, so if you want to use your calculator for that, that is perfectly fine. Okay, so I'll give you a minute right now to simplify what's underneath the radical. and then once you get the value underneath the radical, I want you to look for a perfect square. And you can decide if you want to do that using the factor tree, or you can find the largest perfect square. You can decide. Okay, so negative 16 squared is what? 256. Okay, and then you have 4 times 2, which is 8. 8 times 27, what did you guys get for that calculation? 216. Okay, so when you subtract, you're going to have the square root of 40. Now be careful. We are going to end up dividing both of these terms by 4. You cannot divide this here. If something's inside the square root and something is outside of the square root, you cannot combine them. Okay? You can only simplify numbers outside the radical with other numbers outside the radical. So many of you are going to look at this and know what the biggest perfect square is. Can you guys tell me? It's 4. So the square root of 40 is like root 4 times root 10, right? Okay, so when you simplify, it's going to be 4 plus or minus. The square root of 4 is 2, so that can go on the outside. And then you're dividing each of these. Oops, sorry, I simplified that. You're dividing each of these by 4. So you've already divided that one by 4. For this one, what is 2 over 4 reduced to? Yep, 1/2. So then your final answer is 4 plus or minus. You don't have to write the 1. You can just write it as root 10 over 2. So this is going to be your final answer here. Okay, so the other way that you can do that is by using the factor tree. And I'll remind you how to do that in a later one. All right, and then for B, you have g of x equals 4x squared plus 3x plus 2. So with this one, I want you to do this without a calculator. We're going to be working with some smaller numbers here. Okay, so that negative b that starts here, you might notice I always say the opposite of b. That's so I can just plug it in here. And then when you do the b squared, I always jump and automatically put what that is because I always know it's going to be a positive value. And then I slow it down at this part and I do 4ac. 2 times a. All right, so 4 times 4 is going to be what? 16. 16 times 2, 32. And if you guys want to like save some space and you want to just like write above what that's going to be, that's fine. The 9 minus 32. Okay, and then you have the square root of negative 23 divided by 8. So anytime there's a negative under the square root, what shows up? Yep. So this is going to be plus or minus I root 23 divided by 8. And then there's nothing I can simplify here. So I'm going to leave my answer like this. And then remember, if you prefer to write the I on the side, you can do that. You can put it right there in the middle. All right, now this one is x squared minus 8x plus 10 equals 0. So sometimes they're going to give this to you as a polynomial. This is in function notation. Sometimes they might give it to you equal to 0. In both cases, you're going to do the same thing. You're going to find your a, b, and c, and then you're going to plug it in. So I want you to try part C on your own. And then you will need your calculator for example. So grab that. Okay, and do part C without your calculator, okay? Alright, so looks like this one went pretty well. There is a value underneath the radical that you have to simplify. Okay, so you do x equals the opposite of b plus or minus b squared minus 4ac. So 64 minus 40 gave you what underneath the radical? 24. Now, again, with 24, you're going to know what your biggest perfect square is. If you're not sure, you can always do the factor tree. I think some of you like doing the prime factorization. That's fine too. Anytime there's a group of 2 that comes out, okay, so this is going to be 2 root 6 because 2 times 3 has to stay inside. And then you're dividing each of them by 2. Now, when you get here, you can simplify. 8 divided by 2 is 4. And you can simplify if the numbers are on the outside. So 2 divided by 2 just leaves you with root 6. So this is going to be your final answer. Okay, make sure you guys show this step, the simplification step, so I can see that you know how to simplify the square root of 24, okay? All right, now in example 2, we're going to draw a little picture of this. We have a diver that is jumping from a diving platform that is 10 feet high. So I'm going to have a very basic drawing. This is my happy little diver here. Her arc can be modeled by y equals negative 4.9x squared plus 2.5x plus 10, where y is her height in meters and x is the time in seconds. How long will it take for the diver to enter the water? Okay, so how long will it take for the diver to enter the water? So they're asking you how long, and it tells you that x is the time in seconds. So we have to find the value of x. Okay, if they ask you like what her greatest height would be, you could find your vertex. That's what we did earlier in this chapter. Okay, but this is asking you for how long it will take her to enter the water. So let's draw that as well. Okay, just give me 1 second. Okay, so here's the water, and then we're going to draw her arc. Okay, so she jumps off the diving board into the water, and then we have to find out how long it takes her to hit the water. So we're trying to find this spot here. This is a parabola. It's this other side that you're going to be seeing. I'm going to make that symmetric. Okay, and this is your x-axis. So just like with some of the other story problems we've done, we're going to have to reject one of the answers that doesn't make sense. and we're going to have to find the viable answer. Okay, so because this is in the unit where we are talking about the quadratic formula, we are going to solve using the quadratic formula. On your quiz, there will be a specification that you have to use that. And then I'm going to show you how to plug this in once you do your setup. Okay, so we guys plug in your A, B, and C into your quadratic formula. Oh, that was similar to why you have to multiply before you can add or subtract. Okay, so when you guys substituted this in, this is something that you could do all at one time, but you have to use your proper grouping symbols, which are the parentheses. Okay, so when I'm doing this, one thing I like to do is what's inside the radical first. Okay, so you can do the 2.5 squared. You can use the square symbol. And then it's minus 4 times negative 4.9 times 10. Okay, and then that will give you the square root of 202.25 over negative 9.8. Now, once you get here, notice that you have the plus or minus. So what that means is we're going to do two different calculations. Okay, we're going to do negative 2.5 plus the square root of 202.25 divided by negative 9.8. Okay, and then we are also going to do negative 2.5 minus root 202.25 divided by negative 9.8. One of these answers is going to be our final answer. The other one is going to be rejected based on that we are trying to find the time. Okay, so there's two ways you can do this. I'm going to show you both ways. So one way is you can do negative 2.5 plus the square root of 202.25, press enter, and then if you press the divided button, it's going to use that answer to divide it by negative 9.8. Okay, you want to make sure that you do that so that you do not round until the very end. So it doesn't say what to round to. We'll round to the nearest 100th because that's what it is on your next quiz. So if we're rounding to the nearest 100th, we'd have negative 1.196 dot dot dot. So this 6 is going to press the 9, the 19 up to a 20. Okay, now because this is negative, we are going to reject that answer. Okay, you can't have negative time. I'm just going to write time, not negative. Okay, so we're going to reject that answer. And then I just want you to notice it wasn't the minus one that got rejected. So it's not always the one that is minus that's going to be rejected. It's going to depend on your situation. Okay, and then I'm also going to show you this trick, which some of you probably already know. But if you arrow up and you highlight that, you can do that again. We can just change this to a minus. And then I said I would show you the other way. The other way would be if you put it in all at one time, you have to insert a parenthesis. If you don't, then your calculator does your order of operations for you. And according to the order of operations, they would divide these two numbers before they subtracted here. Because you divide before you subtract in your order of operations. So if you tried that and didn't get the same number that I am here, it's 1.706 dot dot dot. Okay, then that may be what you forgot, are those parentheses, those grouping symbols. So then your final answer is going to be 1.71 seconds. Okay, so that's how long it takes her to hit the ground based on this given equation. All right, now the next thing we're going to talk about is the discriminant. So the discriminant is just going to be the value that's underneath the radical. Do you need any more time for this one? Okay, so the discriminant is useful because it can tell you what your solutions are. So the discriminant is this b squared minus 4ac, which is just the part that's underneath the radical. Okay, and then we're going to use that to find the number and the type of the solutions. So we're going to use it to find the number and the type of solutions that a quadratic equation has. So if it is positive, there are two cases. You can have b squared minus 4ac be greater than 0, and it's a perfect square. Okay, so if b squared minus 4ac is greater than 0, and it's a perfect square. If that happens, then there are two real, and so if they're real, they're not imaginary, and they are rational roots. Okay, if something is rational, We're going to write up here what that means. If it's rational, it can be written as an integer. Do you remember what integers are? Whole numbers, positive and negative, and 0. So it can be written as an integer or a fraction of integers. And often this is called P over Q, where P and Q are both integers. So that would be like 1 over 3. 1 and 3 are both integers. It would be negative 2 over 7. Negative 2 and 7 are both integers. Okay, so that's what it means by rational roots. If it is not a perfect square, but it is still greater than 0, so if you have b squared minus 4ac, it's greater than 0 and is not a perfect square, then you still have 2 real roots, but they are irrational. Can you guys think of some irrational numbers that you talked about in previous classes? There's some popular ones. Some of them are symbols. Pi, yeah. First I thought somebody said I. Yep, pi, square root of 2. So a lot of our square roots, those are irrational values. Okay? So we're going to draw what this looks like on the graph. If you have 2 real rational roots, or if you have 2 real irrational roots, you are going to have 2 x-intercepts. And it doesn't matter where you draw your parabola as long as you have the 2 x-intercepts. Okay, so if they're rational, they're going to cross at those whole numbers and the fractions that have integers. Okay, now if it is 0, if you have b squared minus 4ac and it's equal to 0, think about what happens when you take the square root of 0, right? The square root of 0 is just one number. That's why it's going to produce 1 rational root. Or sorry, 1 real rational root. Okay, so 1 real rational root. Now on your graph, if you only have 1 real rational root, that means the vertex is on your x-axis. So it could look like this. Okay, the vertex is on the x-axis. And then if it's negative, your b squared minus 4ac is less than 0. There are going to be 2 roots this time, but they are not real. They are imaginary, and we call those complex. Okay, so you're going to have 2 complex roots. Okay, so complex means that you have imaginary. It's that a plus bi form. And you cannot see imaginary values on your graph. Okay, you cannot see the imaginary roots or the complex roots on your graph. So if you have imaginary complex roots, there are no x-intercepts. Okay, so we're going to be using that as a guide for our next set of examples, where it's asking you to find the type and number of solutions for each equation. Okay, whenever you have to find the type and numbers for each equation, that means that you are going to find the discriminant as well. So make sure you know what that word means. Okay, we're going to find the discriminant for all of these. Okay, so our A value is 1, our B value is negative 12, our C value is 36. We're going to plug this in to B squared minus 4AC. Okay, and like I said, I'll usually do the first one in my head, negative 12 squared minus 4AC. If you like writing that part out, that is fine as well. So what is negative 12 squared? 144. Okay, and then we're going to do 4 times 36. That is a fine one to do in your calculator. And then will you write what your discriminant is? So what is 4 times 36? 144, so you get 0. Okay, so your discriminant is 0. We can abbreviate there. And then we're going to do the number and the type of solutions. So if it's 0, we know we have one real rational root. Okay, and then let's do B. And you don't have to write out like your A, B, and C each time. If you want to just jump to plugging it in, that is perfectly fine. So every time you're doing B squared minus 4AC, so this would be 144 minus 4 times A times C. We should do this one without a calculator because 4 times 40 is what? 160. Okay, and then we can just do 160 minus 144, right? Or we can add up. So it'd be negative 16 because the 160 is bigger, so that's your discriminant. Now, anytime it's negative, you're always going to have the two complex roots. Okay, now for part C, be careful because this is on the other side of the equal sign. These were equal to 0, so what we have to do is we just have to make sure that this is going to be equal to 0. So we're going to add 30 to both sides. So make sure that you use a positive 30 for your C value. Okay, and this is another good one that I want you to do without your calculator, okay? So I'll give you a minute to do that and then fill out the discriminant and how many solutions there are. Okay, and again, so some of these on your homework, you can use your calculator. I really want you to push yourself to use mental math when you can. See, like the ones that end in 0, those are good practice because 4 times 3 is 12, so it's minus 120. So what did you guys get for your discriminant? 24. Okay, so then all you have to do is ask yourself, is 24 a perfect square or is it not a perfect square? Not a perfect square. So if it's not a perfect square, we're going to write 2 real irrational. Okay, and then I want you to do this one. This is another one that I think you can do without your calculator, okay? Okay, so you had to move over your 3, so you subtracted it. Yeah, if you guys need your calculator to check to see if your number is a perfect square, you can do that. Okay, so then your b squared minus 4ac, okay, is going to be 7 squared, which is 49, minus 4ac. Now, in this one, you have a negative times a negative, right? So when you do a negative times a negative, that's going to end up being what? A positive. Okay, so negative 4 times 2 is 8, so this is negative 80 times negative 3. What's 8 times 3? 24, so it's 240. Okay, so then you get 289. How can you check to see if that's a perfect square? Yeah, you take the square root, and if the square root is a whole number, then you know it's a perfect square. What's the square root of 289? 17, so it is a perfect square. So your discriminant is 289. Okay, and then you have 2 real rational roots. Okay, so you guys do need to make sure that you're writing that out. That's also going to help you remember it for your quiz. And then there is one other thing I want to show you. So you guys flip it back to the front. So I just want to put like a little note here because there is one more type of situation you're going to encounter. Do you guys ever have the fun scissors that have like the cut out the fun edges? Because that's what that reminds me of. Okay, so the other type of equation that you might see when you are doing this is you might get a perfect square underneath the radical. So I want you to know what to do in this case because it caused some confusion. Let's say you're doing the quadratic formula and you get 8 plus or minus 25, the square root of 25 over 2. Let's say that you get this. We're just going to jump here. We're going to make this a little bit shorter. So if you took the square root of 25, you would get 5. And so we know that this is a perfect square. That's going to simplify. So you have 8 plus or minus 5 divided by 2. Now, when you get there, remember, you can actually do this. You can do 8 plus 5 divided by 2, or you can do 8 minus 5 divided by 2. So in this situation, you are going to have to simplify. So we're going to do the 8 plus 5, which is 13 divided by 2. That's going to be one of your answers. Or 8 minus 5 is 3 divided by 2. That is your second answer. Okay, so in some cases, you won't have a square root, and you do have to make sure that you simplify that. Okay, so when you see that on your homework, just make sure that you keep simplifying.